We are building enhancements to the secret message activity from the YByte Python curriculum available at www.ybyte.in. In the last video, we saw this thing called the Railfence cipher, where the idea is that we have multiple rails. We write our message across these rails and then read them out in a certain way so that the message gets encrypted. Now, this being a substitution cipher, the decoding is all about sending letters back to where they came from. This is the same thing in the Railfence cipher. In fact, there's a very, very clear pattern. But despite this, decoding, as we'll see in this video, will get a bit involved. So very logical, however. So before I get started with this video, keep in mind that this is a bit involved, but extremely interesting. The way we go about this is quite interesting. With this preamble, let's say prelude set, let's get moving. Like I said, decoding is all about bringing the letters back to where they came from. Now remember, the way this Railfence cipher works is I write my message across rails and read them out rail by rail. Now, in this case, what's going on is that, for example, the first four letters, which is the first sort of, chunk, have come from row number 0. Now, how do I know there are 4 letters over there? Well, basically, that's just the number of units that I have in this. Remember, I defined a unit as this. And you can, more formally, we can say that the length of message divided by 2n minus 2 is the number of units. Now, it turns out that in this case, length of message is 16. N is 3 and hence 2n minus 2 is 4. So 16 by 4 is 4. Now this is important because each of my row is contributing, for example, the 0th row is contributing 4 elements. The first row is contributing 8 elements. The third row is contributing 4 elements. Now all I really need to do is that every row, I just kind of break my message into chunks. Every row, I put them back into the exact same positions where they came from. That's what we are going to do. Let's see this again for 4 rails. Now, once again, C in this case is 3, which means each row is contributing, say 3 elements or 6 elements. So, for example, the 0th row contributes 3 elements. So, which means that in my decoding, I can look at these 3 chunks, this chunk of 3, let's say, and I can send them back to where they came from, which is actually known to me because the way we have encoded. Next, I can look at row number 6, row number 2, row number 3, so row number 1, row number 2, row number 3, and so on. And that way I can actually send all the messages back to where they came from and restore back my original string. So that's the idea. Broadly speaking, the steps we are going to follow is, like I said, extract every chunk from the coded message. Now notice that there are totally n chunks, n being the number of rails, each corresponding to 1 row or say 1 rail. For the 0th and n minus 1 chunk, there is only 1 slice because remember this, as this diagram tells, and we saw in encoding, there's only 1 slice we are looking at, and we know exactly where these letters came from the encoding process, then which means that we can just send them back to where they came from. We can create a decoded message and populate exactly those positions. We'll see how this is done. For the middle rows, however, there is a little bit more logic to it because remember there are 2 slices that we are doing which are sort of interleaved. For instance, this and this is 1 slice, N, O, and this is say another slice which have been interleaved, which means that if I look at this chunk, the 0th, let's say within this chunk, so 0th, 2nd, and 4th letter is sort of 1 slice. 1st, 3rd, and 5th is another slice. So we can, basically extract both these slices. Once we have done this, then we know exactly where they came from because, for example, Y came from here, I came from here. This is again a pattern. So we can, do that for both the even and odd slices. Of course, there is more to it in the sense that the devil is in the detail. The exact numbers is where it gets a little bit, confusing. But this is the logic. Let's look at each of these steps a bit carefully. Extracting each chunk from the coded message. Like I said, there are n chunks. That's all right, because there are n rows, but the challenge here is that the length of these chunks is not equal. So what happens is, for example, the first row, or say the 0th row, in this case, C was 4, so I got 4, elements on that. Next, in the row number 1, I got 8, exactly twice of this, and then I got 4 again. In fact, in n equals to 4, I got 3, and with my length being such, C was 3, so I got 3 elements on the first chunk, 6 in the next 2, and then 3 again. And this is again really, you can just go back to this and you can just see it off here, right? For example, 4 rail case, I got 3 in the first row, 3 in the last row, which means my first chunk and last chunk is 3 and 3. Both of these have 6 and 6 because remember before encoding we had made sure the length is such. Now what that also means is that the indices for these, so I can extract these chunks with slicing for sure. but the indices for these have to be carefully computed. This is not equally spaced. For example, here 0, next one starts at 4, next one starts at 12. Here it's 0, 3, add of 6, so 9, 15, and so on and so forth. So we have to be a little bit careful here. It has to be done quite, let's say, meticulously. What I have done here now, again, this may look like a lot of information suddenly, but go through it slowly. I have written down for you what is the starting index and stopping index for every chunk. For example, 0th chunk. Now, this is with respect to the decoded message. Remember, the 0th chunk is always the first few elements. In fact, the first C elements. So, which means that my, for chunk 0, it will be 0, ending at, so stop index will be C minus 1, and the step will be 1 because I want all those elements to be extracted. For chunk 1, even and odd, basically chunk 1 would be, so chunk 1 would be, let's say 3. I let the 3 go. I start counting from here every even number, right? And the chunk 1's odd value would be every odd number here. And if you see carefully, that's what I'm doing. Only keep in mind that the first chunk is going to be 2 times C, not C. And as we saw, 3 became 6 and so on. The last chunk, on the other hand, will be, will be starting from C plus n minus 2 times 2C. Now, again, this should not surprise you. Remember, there are totally n chunks, out of which n minus 2 are of length 2C. So, which means there are n minus 2 times 2C plus C for the very first chunk. So, that's here. I come to this point and then I just read off all the values. So, that's my last chunk. Now, in general, again, this is just generalizing this. Basically, for the kth chunk, where k is between, it's a 0 and n minus 1. So for the extremes, anyway, it's clear for the kth chunk. Otherwise, this is the formula. Now, you can look at it carefully, try to convince yourself. I'll also be able to happy to discuss with you. But again, it's very, very logical. The simple fact we are using is first chunk is C. Thereafter, every chunk is, say, 2C. So depending on the number of chunks, you will have those indices formed. I'm going to use this in the code. So what we are going to do really is that we are going to extract these slices in the decoded message. Now, first thing, I'm going to define C, define M, as we have done before, and then I'm going to use this code. So let's just do this much first, and then we'll see how to proceed. So I go to my, my code here, and I just say, okay, let me just define a new function called, let me just start from here. Let's say, so I say this, I just go and say, all right, let me just copy this whole thing over. So I say define Railfence cipher, say decode message, and I tell the number of rails. I do what is say M, and I also compute the C, because C, remember, is the length of the chunk. So I just say C is int, say, length of message, say GE by, say, M. Sorry, this should be M. Oops, M here, right? So that's my C. Now, I don't need to do this because the message is expected to be of the right length. So I don't do anything here. I just want to write the first piece of code to basically extract out all the different chunks, right? So I again say KK in range n because there are n chunks, because there are n rails really. So I just go and look at each of those. So if KK, for example, is 0, remember KK equals to 0 means I'm looking at the very first chunk, the very first 3 elements of the string, or C elements of the string, sorry. I just say, start from 0 and I go all the way to C in step 1. So this will give me 0, 1, 2 until C minus 1, depending on what the C is. Next, if I just write my code, let's say elif, say, elif, okay, maybe, yeah, elif, say KK is equal to, say, n minus 1. Now, notice this time around, I'm not able to put these two together because the formula are a little bit different. So I say temp. Now, again, remember, for the n minus 1 case, temp would be message. So say message. In this case, it will be C plus, say, n minus 2 times 2 times, say, times C. Now again, nothing to feel confused over here. There's one block with C elements. There are n minus 2 blocks with 2 C elements, and that's exactly what I've done. Going all the way to the end in steps of 1. So that will be my last sort of chunk. That's K equals n minus 1. When it comes to the other ones, remember, I'm going to be extracting 2 chunks, and this is a little bit, let's say, painful. So let's just do it slowly. So I'm going to extract the first chunk as, let's say, so I'm going to do this a little bit slowly. So C plus, say, KK minus 1 times 2 times C. Uh, in steps of so I'm going to do C plus KK minus 1 times 2 times C in steps of 2, and the ending would be basically just this plus 2C, because remember the chunk we are looking at has a length of 2C, and I must put that as the end. So let's make this a little bit bigger, do it slowly. Times 2 times C plus 2 times C. Right, so this is my temp 1. I'm going to just copy this, and let's say I'm going to do temp home, and temp, say, 2 here would be essentially just the same chunks but offset by 1, because this must be, say, 1, the odd, the odd version of it, right? So exactly everything remains exactly the same, because I start somewhere else, everything else remains exactly the same. Now, having done this, let's just, I'll just remove all this for now because I don't need this stuff. What I will do is that I will just look at, let's say, in this case, in each of these, I'll just print, let's say, print, say, for example, KK and temp. So I know what is being printed. I will also print, let's say, again, here, print, say, KK and temp. And again, I'll say print, let's say, KK temp 1, say temp 1 and temp 2. Right, let's just see what this does. Of course, I don't need to return any s and all that here right now. Now notice this code right now is only extracting, so I have a mistake here, let me fix that. It's only extracting those those slices, and we are just going to print those. Just to understand what's going on here, so I run my code. I will just say, let's say, for example, x, let's say rf is rail, so Railfence, say, cipher, say Python is cool, and say with 3 rails, right? If I do this, so I get something here. Now I'm going to just decode this. So I just say, rail, say Railfence, say cipher, cipher, say decode, and I gave, for example, x underscore rf and 3. Now notice I get, for KK I've got POSO. For for KK equals 1, I've got, let's say, 2 chunks here, temp 1 and temp 2, and finally I've got this TC. Now how do I make sense of this? Well, because if I look at XRF, remember the first chunk has 4 values, so POSO, so that's been picked up, then the KK equals 0. Next, I have picked up the basically slices of this chunk, right? And what are those slices? Well, those are basically Y, N, space, and L, and in this case, H, I, and O, which makes sense. And there's a space here, it doesn't show up, right? Finally, I've picked up the last chunk, which is TC. So this all I've done. We can take one more example. Let's say I did the same Railfence cipher with, let's say Python is cool with, say, 4 rails. Now I just go and decode this again. This time round, I say decode with, say, 4 rails. So again, let's look at XRF. That was this. Now remember the first, this in this case the C is equal to 3. So I picked up the first slice P dash O. Next, I've picked up the the next 6 letters, which is basically this slice, but again I have gone further to slice them. So it's YIL and NO space, TS space, OC space again, and then finally I've got only an H and with these spaces. So that how I've split this whole string. Yeah, that's all I've shown you so far. Yeah. So now comes the most interesting stuff of this, as to how do I move these guys back to where they came from. Now remember, I've extracted out these chunks. Let's look at kk equals to 0. Now remember, from the encoding process, we know that the kk equals to 0, which means the first rail, really contained message, every mth element of that message, right? Basically like 0 colon colon m, that's what I had. For example, 036 or 048, whatever, that was the first row, where m is the original message, uncoded message, and m is so the message is uncoded message, and m equals 2 and minus 2. So way I'm going to do this, and this is really interesting actually, is that I have got a temp. Remember, this temp is a string. I'm going to move every element of this to locations given by this. So what I've done is that I'm creating a list here. Notice this is a list, not a string. I'm creating a list here of empty characters, m of those, and then I just run a loop on this temp, right? So basically this loop is running on this temp. This pp goes from 0, 1, 2, 3, 4, and so on and so forth. Interesting bit of this loop is that I'm running in a range not usual my m. I'm running this in the range 0, length of message m. Now why do I do this? Because remember, this range will generate the sequence which is basically these indices. So if I look at this range, is going to generate the right set of sequences for me, and I'm going to put this characters in, let's say, this DCD list. Let's do this much first, and then we'll continue, because it makes it clear as to what we're trying to do here. So what I will do is that I will just go to, remember this was for kk equals to 0. I will remove this print for now because we don't need this. So first thing first, I'm going to create a DCD list, which is basically a list of, so I just create an empty character, list of empty characters, and I create, let's say, length of, the message. Basically just as, so I'm creating a list as long as the message itself, because that is going to hold my decoded string, right? Now notice this is a list, not a string. There's a reason for this. We'll talk about that later. Now here I've extracted the first, let's say, first chunk. I just run this small loop here. I say pp equals to 0. Now pp is just a random, let's say that's a local counting variable. I'm going to say for in range. Now this is very interesting. Please take a look at this. So I said range, let's say 0, length of, say, message, and say, in steps of m, right? Because notice I just want to get to the indices from where the message had come. So I go to each of those indices on the list. Now there's something wrong here. I need to fix this. 0 colon, what could be wrong here? Oh, okay. So the range function, I do not need colons. I need instead the commas, right? So I will, so there's not slicing, but it's going to work quite similarly. Now I'm going to just say DCD, say list. So let's be careful here. Say DCD underscore list, say mm is equal to temp, say pp. Now notice I'm counting through every element of the string temp, and adding it to the right position on the DCD list. And I say pp equals to pp plus 1. Now, just for the sake of clarity, let's just print over here. For example, I will just do this here. I'll print, for example, say print, say mm, and I will also, once this loop is over, I will also print, let's say, print, say, DCD list, so that it becomes somewhat clear as to what we are trying to do. Let's just run this. Notice I've done it only for kk equals to 0. Let's make sure this code is all fine. So I will, again, as usual, I will have my x, say, xrf, xrf is equal to, say, Railfence. Maybe I should make this part of the code. So Railfence cipher, let's say, Python is cool, and I do this with 3, let's say, 3 rails. Now when I decode this Railfence cipher, say decode, I will do xrf and say 3 rails. Now I just want you to see what has happened on the on the list, DCD list. Now first thing first, notice that my went 0, 4, 8, 12 in this for loop, because of the way the range is set up. Now this range is basically a sequence of numbers starting at 0, steps of m, and going all the way to the length of message, right? So that's why I get the 0, 4, 8, 12, and as a result, my DCD list 0th element has become P, then O, then S, and you can see how the decoding is actually started, because I managed to send my letters from my first chunk to where they had come from, because this is exactly where they had come from. In fact, I'm just going to continue with this, so let's close this here. I'm going to go to my, let's say, the last chunk over here. Now, in case of the last chunk, what I'm going to do is I'm just going to take, let's say, the chunk has been formed. Let's remove this. I'm going to just run a very similar loop. Only thing that I'm going to change is, let's say, the range function, so that I get to the right, let's say, values of the range. And all I need to do really is that here I'm going to say kk, len of message, and m, right? So, and everything else remains the same, because here I'm looking at a different range. And let's see this now. Again, if I did, for example, sorry, my bad here. So notice once again, I'm going to print, for example, the DCD list over here for the, at the end of this code. So I say print, for example, DCD, say list. Now, again, this is interesting because when I run, so maybe I'm just going to set my screen to say up and down. It's a bit easier to see for this code. Okay, the settings, I'm just going to make it, let's say, instead of this, I'm going to make it stacked and say, yeah. So this has become a little bit easier for me to see. When I run this code now, notice what happens. So I do this again. So I just say xrf is equal to say rail fence, say cipher, say python is cool, say cool, oh, and oops, say 3 rails. When I do this now, when I decode, so I do say, for example, rail fence cipher, say decode, and I do xrf comma 3. Notice what happens is that I get my, oops, to go down. Now see how my fourth rail, my third row is also being formed. First thing first, notice my first time the loop ran, went from 0 4 8 12. Next time the loop has gone to sorry, actually the loop, next time the loop has gone through 2 4 6 and 14. That's because that is where my elements from the last row have to go, and that's exactly what is going on. You can already see this forming p dash t dash, and so on and so forth. You can kind of see that this thing is forming up because again I managed to send back my last row's elements into the correct position. Now let's just continue with this. I'm going to get on with the middle rows as well. And basically the idea is very similar. So I'm going to remove, let's say, this print statement, and here I just go and write again a little bit of code here. All I need to do really is that I just, I'll take, let's say, okay, so I've got temp1 and temp2. So let's just copy, say, this piece of code here. So I copy this piece of code over here. Now I just have to do it once after temp1 and once after temp2. So I do this. Now again, notice this has to be temp1, and I just have to be a little bit careful. In fact, it turns out that this is absolutely correct because remember my temp1 is still at a spacing of m and starts at kk. However, for temp2 I'll have to be a little bit careful. So I will have to do this. Let's say, so I come in here and I put this code over here and I say, okay, look, for temp2 it is going to be, instead of kk it will start at m minus kk. Now again I'm printing m, so that kind of printing which is a counter, kind of helps, and this has to be temp2. Now with this done, it's actually quite interesting. I'm just going to run this code once again. So I go and do, for example, let's say x rf is equal to say rail fence, say cipher, say python, say is cool, and with say 3 rails. So when I run this now, I'm going to decode so I just go and say so rail fence cipher, say decode, and I put xrf comma 3. Now what I want you to notice is how, notice, in fact my entire message has been formed by the time I come to the last row. And how did this happen, right? Let's go through this one by one. I first encountered the first row, my went from 0 4 8 12. Remember, this is where the messages have come from, so I start populating my list. Next I go to the first row. I got 2 slices. The first slice came from 1 5 9 13. The third slice, the second slice of that came from 3 7 11 15. Next I went to 2 6 10 14, and my entire message is formed. So I'm going to remove these prints because they kind of obscure the view. So I just remove this, let's say, print DCD list. But what I'm going to do next is to change this into, let's say, a string, because remember this is a list right now. I'm going to change this into a string, and for that purpose, all I need to do really is to get out of all of these loops, right? So I've created so here I'm running through this entire thing over here. All I'll do really is at this level of indentation, I will go and change this to a string. So I'll just call it, let's say, an empty string. And I will just say, okay, look, for letters in, let's say, DCD list, So every letter I just want to kind of append it to the string. S is equal to s plus letters. And with this done, I can say return s. Now this is actually quite interesting. Obviously a bit involved. So if I run this now, let's just see this once again in action. So this time around, I'm going to use, let's say, xrf is a rail fence, say cipher, say uh, python, say python is cool. Let's say I do it with 4 rails. So I get something, now I'm going to decode this. So I say rail fence, say cipher, say decode, and say xrf, let's say 4, because I'd use 4 rails. And indeed, so it still prints those we can remove those as well. But notice I got back the string that I was looking for. Python is cool. Like really, really super cool this is, right? So I'm just going to remove these prints because they are unnecessarily obscuring my view. After this, I'll also show you the code that I've done so that you can, kind of understand this maybe a little bit better. It is involved, but very, very logical. The important bit here is how we have used the range function, to give us these different values. Because remember, we want to map this back to where this had come from, right? So once again, the code, we have done this before. Kk equals 0, I went in the range 0, length of message to m. For kk equals to, so for kk equals to n minus 1, I just went from kk to length of message to m. Again, we saw how works out. Next, for between this range, there are 2 lists. So first I do for one list here. This is straightforward. Kk starts at kk steps of m. We have talked about this before. And, finally, for the second one, again, remember the message is going from m minus kk. I mean, this is where it had come from. So I just run my range function that way. And I get my elements back to where they were, and using this for loop. So this is kind of, for the temp2. And with all this done, all we did was to convert this to string and present it back, right? Return it back. Now, one food for thought, why did we do this DCT list, and why not create a string right away, which we could, with which we could write values? Think about it. I'll be very happy to discuss. But I hope you found this interesting. Certainly, this is involved, but very logical. And see how powerful programming is. We are able to do so many things with it. In general, if you find that this way of learning is fun, it makes you think, it makes you understand things better, look at our website because there are many, many, many such activities there for you. Take care. Thank you so much. Bye bye.